We recognize a horizontal expansion as happening when the graph stretches in the horizontal or x direction. A horizontal compression, on the other hand, has the graph being squished in the horizontal direction. In equation form, we'll recognize the horizontal expansion or compression by noting the multiplier beside the x, and we'll call that b. Whether it's a horizontal expansion or a horizontal compression simply depends on the number being multiplied, or the value of b. If b is greater than 1, then we recognize it as a horizontal compression. If b is between 0 and 1, we recognize it as a horizontal expansion. Now, let's stop and recognize that this may seem a bit inconsistent with the vertical compression or expansion, with our multiplier a. Given that, if we were to put a out with the y, in the same way that the b is right beside the x, we see that in fact they're quite comparable. That is, we look at the reciprocal to identify our multiplier. If b is greater than 1, then our reciprocal, or our multiplier, is less than 1, and we have a horizontal compression. If our b is between 0 and 1, then the reciprocal, or the multiplier, is now greater than 1, and we have a horizontal expansion. Example 1. Write the equation of the function shown in this graph. And we start by recognizing that this is a quadratic function, or degree 2. And we also see it's reflected vertically. So we can easily put a negative right out front here. So are we done? Well, things look pretty good, except for this graph seems wider than our standard quadratic. So let's see if this is true. Now, a standard quadratic with a vertical reflection would cross through 1, negative 1. And our graph doesn't pass through this point 1, negative 1. Instead, it passes through 2, negative 1 here. So yeah, our graph is definitely wider than that base. To describe this horizontal expansion, we'll recognize that the multiplier is 2. The x value was multiplied by 2. So the reciprocal of 2 is 1/2. And that's our coefficient in with the x here. The equation describing this graph would therefore be y equals negative, and then in brackets 1/2 x all squared. Now we need those brackets to show that the 1/2 is impacted by the squared, along with the x. It's truly in with the x, which is needed to indicate a horizontal expansion. So let's confirm. When x is 0, y is still 0. When x is 2, y is negative 1. When x is negative 2, y is negative 1. And it all fits well.